Hello everyone, welcome back to the Decode with Pankaj. This is part 3 of the SPPU 2019 pattern, third year AIML MIDS question paper solution. In this video, we are going to solve question 5 and question 6 with simple explanations and exam oriented answer. So let's continue the paper solution. What is decision tree and how does it partition the feature space? Okay, so it is a 6-mark question. So firstly, what is decision tree? A decision tree is a supervised learning algorithm used for classification and regression. It represents the decisions and their possible consequences in a tree like structure. Okay, the structure of decision tree is like a same as tree. Okay, like in the design analysis of algorithm we study in second year or last sem, so in which we get the minimum spanning tree, in which what we do, in which we get the root node. After that we get 3 or 4 multiple nodes, parent node. After that we get multiple child node, and then we get 2 node for each node, and using this type of structure we get the overall our minimum spanning tree. Okay, the same concept as it is in here. The structure of decision tree is root node. So what is root node? Root node, it is a node, it is a first node like main node. Root node represents the entire data set and the first decision. Okay, so internal nodes means also it known as like a parent node. Okay, so internal nodes represent the tests on the feature. Okay, like we get the data in this, we get the features, like feature means column, different column. So for that particular we get the internal, it represent the tests on that particular features. Okay, so next is branches. What is branch? Branches, it is a branches, what it is a nodes. So branches represent the outcome of the test. Okay, and the leaf node, it is a child node also known as, so it is a last node with connected with internal nodes. Leaf nodes represent the final class labels or outputs. So partitioning of feature space. A decision tree partitions the feature space into smaller regions using recursive splitting. Recursive partitioning. So first is recursive partitioning, in which the dataset is split repeatedly into subsets, and each split is based on a feature condition. Axis aligned splits. Splits are generally of the form x is greater than or equal to c, or x is greater than c. Okay, so this creates rectangular regions in the feature space. So next is hierarchical division. Each split further divides the data into more homogeneous groups. The first homogeneous groups, and the process continues until the stopping condition is reached. Okay, so it is also done in hierarchical division. Okay, the next is stopping criteria. Stopping criteria is maximum depth reached, minimum samples in a node, and no further information gain. Okay, like entropy gain, information gain, the all concepts are used in stopping criteria. The conclusion of this answer is decision trees divide the feature space into a smaller homogeneous regions, make it easier to perform classification or regression. So next question is, what is entropy and how it is used to construct the decision trees? Okay, it is also 6-mark question. So first is we get the definition of entropy. What is entropy? Entropy is a measure of uncertainty or impurity in a data set. Like our data set have multiple types of data. Okay, so in which we get the clean data, and in which like how much percent of impurity, like how much percent of null values or overall that uncleaned or dirty data, that is used in entropy. Entropy is a measure for the uncertainty or unimpurity in data sets. Okay, formula for entropy is HS is equal to summation of pi log to pi. So where pi is the probability of each class. Okay, properties of entropy. If entropy is equal to 0, then data set is completely pure, all instances belong to one class. And if entropy is maximum, when classes are equally distributed. Using entropy used in decision trees construction. First step is calculate entropy of data set, in which measure the impurity of the current data set. The step 2 is split based on features. in which we get try different features to split the data. Step 3 is compute information gain, in which information gain is equal to reduction in entropy after the splits based on the features. Okay. Step 4 is select best feature, in which we get we choose the features with highest information gain. And step 5 is repeat recursively, in which we continue until stopping condition is met. Okay. So information gain formula is Ig is equal to h of s minus summation of SV divided by S into H SV. The conclusion is entropy helps in selecting the best feature for splitting by measuring impurity and maximizing information gain. Okay, so next question is question 5C. What is random forest and how does it combine multiple decision trees to improve accuracy? Okay, so firstly we get definition. Random forest. Random forest is an ensemble learning method that builds multiple decision trees and combines their predictions to improve performance. It is also used for the prediction. And the working of random forest is first bootstrap sampling, means bagging, in which multiple data sets are created using sampling with replacement. Each data set is used to train a different decision trees. And second is random feature selection, in which at each split only a random subset of features is considered, and this increases diversity among trees. The third one is independent tree construction, in which each tree is trained independently. The fourth is final prediction, in which same as like before we tell us or we discuss us. Classification gives the majority voting and regression gives averaging. Okay, so how it improves the accuracy? Accuracy improvement in random forest we get reduction of variance. Averaging multiple trees reduces fluctuations. Second one is reduction of overfitting, in which unlike a single decision tree, random forest generalize better. And the third one is improve robustness, like less sensitive to noise and outliers. The advantages is high accuracy, handles large data sets and work well with high dimensional data. And the limitations is less interpretable, requires more computational resources. And the overall conclusion of this answer is random forest improves the prediction accuracy by combining multiple decision trees using bagging and random feature selections. Okay, so next question is question 6A. What is boosting and how does it iteratively adjust weights to improve accuracy? Okay, so first of all we get the boosting. What is boosting? Boosting is an ensemble method that we discussed previously. Boosting is an ensemble method that combines multiple weak learners to form a strong learner by training models sequentially. The working of boosting, in which first is initialization, in which all training samples are assigned equal weights. The second one is train first model, in which a weak learner is trained on the dataset. Third one is identify errors, in which we misclassify the samples that are identified. Fourth one is update weights, in which we do increase weights of misclassified samples and also decrease weights of correctly classified samples. The fifth one is train next model, in which we get the next model focuses more on difficult misclassified points. And sixth one is repeat process, in which we continue training multiple models sequentially or iteratively. And the seventh one is final prediction, in which we combine predictions using weighted voting. The key idea of overall concept is each model learns from the mistakes of the previous model. It difficult samples to get more attention. And how it improves accuracy? Because it reduces bias by learning complex patterns, focuses on hard to classify data points, and builds a strong predictive model from a weak learners. And the conclusion of the overall answer is boosting improves the accuracy by iteratively adjusting weights and focusing on misclassified samples during the training. The next question is what is XGBoost and how does it improve on gradient boosting algorithm? So in which it is also 6-mark question. So first is, what is XGBoost? XGBoost is extreme gradient boosting. It is an advanced implementation of gradient boosting designed for speed and performance. Working of XGBoost, it builds tree sequentially. Each new tree corrects the errors of previous trees, uses gradient descent to minimize loss function. Improvements over gradient boosting is, first, regularization, in which adds L1 and L2 regularization. It also prevents from overfitting. The second one is parallel processing, in which it fasters training using parallel computation. The third one is handling missing values, in which it automatically learns best way to handle missing data. The fourth one is tree pruning, in which we uses depth first approach and prunes unnecessary branches. The fifth one is weighted quantile sketch, in which we efficient handling of large data set. And the sixth one and last one is sparsity awareness, optimized for a sparse data. The advantages is high accuracy, faster than traditional gradient boosting, handles large scale of data efficiently. The conclusion of the overall answer is, XGBoost improves gradient boosting by adding regularization, speed optimization, and better handling of the real world data challenges. Okay, so next question is, how do you evaluate decision trees on ensemble models performance and what is metrics are used? Okay, so how do you evaluate decision tree or ensemble model performance and what metrics are used? Okay, it is also 6-word question. So firstly, evaluation of models we get, it is a third time repeat question, like in question 2nd, question 4th and question 6th. It is also same question which is repeatedly again and again. Okay, so note that, like this question is very important, like evaluation of models, in which we get confusion matrix, accuracy, precision, recall, and F1 score, log loss, and cross validation. Okay, so evaluation of matrix is, decision trees and ensemble models are evaluated using classification or regression matrix depending on the task. The first is confusion matrix. It shows true positive, true negative, false positive, false negative. The accuracy measures overall correctness. Accuracy is equal to TP plus TN divided by total. Precision is measures correctness of positive prediction. Precision is equal to truly positive divided by truly positive plus falsely positive. The recall, it is also known as sensitivity. It measures ability to detect positives. Recalls is equal to truly positive divided by truly positive plus falsely negative. Then fifth is F1 score. F1 score is harmonic mean of precision and recall. It useful for imbalanced data set. F1 score is equal to 2 into precision into recall divided by precision plus recall, and ROC curve plus AUC curve, area under curve. Okay, so ROC curve and AUC measures model performance. Log loss measures errors in probability predictions, and lower value indicates the better model. And cross validation is splits data into multiple parts, ensures model generalization. And next is for regression, if applicable, we use mean squared error, root mean squared error, and R2 square error. Okay, so conclusion of the overall answer is, the model performance is evaluated using multiple metrics such as accuracy, precision, recall, F1 score, and ROC AUC to ensure reliable and robust predictions. Okay, so this was the end of part 3, where we solved question 5, question 6 of the MIDS question paper. I hope this video was helpful for your exam preparation. If you enjoyed the content, don't forget to like, subscribe, and decode with Pankaj, and share it with your friends. Thank you for watching, and I will see you in the next part.